ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಕರ್ನಾಟಕ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಅಕಾಡೆಮಿ ಕಡೆಯಿಂದ ಶುಭಾಶಯಗಳು. ಭಾರತ ಸ್ವಾತಂತ್ರ್ಯದ ಅಮೃತ ಮಹೋತ್ಸವದ ಸಂದರ್ಭದಲ್ಲಿ ಅಕಾಡೆಮಿಯ ಜೀವಮಾನ ಸಾಧನೆ ಪ್ರಶಸ್ತಿಗಳು ಗಳಿಸಿರುವ ಸಾಧಕರಿಂದ ವಿಶೇಷ ಉಪನ್ಯಾಸ ಮಾಲಿಕೆಗೆ ನಿಮ್ಮೆಲ್ಲರಿಗೂ ಸ್ವಾಗತ. ಇವತ್ತಿನ ದಿನ ನಮ್ಮ ಜೊತೆ ಪದ್ಮ ವಿಭೂಷಣ ಡಾಕ್ಟರ್ ವಿ.ಕೆ. ಆತ್ರೆ ಅವರು ತಮ್ಮ ಉಪನ್ಯಾಸವನ್ನು ಕೊಡಲಿದ್ದಾರೆ. ನಿಮಗೆ ಸ್ವಾಗತ ಕೋರುತ್ತಾ ನಾನು ಮುನ್ನೆ ಹೋಗುವ ಬಯಸುತ್ತೇನೆ. ಗುಡ್ ಮಾರ್ನಿಂಗ್, ಗ್ರೀಟಿಂಗ್ಸ್ ಟು ಎವ್ರಿವನ್ ಫ್ರಮ್ ದ ಕರ್ನಾಟಕ ಸೈನ್ಸ್ ಅಂಡ್ ಟೆಕ್ನಾಲಜಿ ಅಕಾಡೆಮಿ. Welcome to the special lecture series by Lifetime Achievement Awardees of the KSTA on the occasion of the Bharata Swatantra Amruta Mahotsava 75th Independence Day coming up in the next 11 days, 15th August 2021. Today we have with us esteemed guest Padma Vibhushana Dr. V.K. Aatre Sahab, former Director General of the DRDO and ADA and scientific advisor to the Defense Minister, as also presently the Chairman of Board of Governors of the IIEST West Bengal. So we have great pleasure in welcoming you. We also have with us Professor B.G. Mani, member of the KSTA, Dr. A.E. Eknath, member KSTA, my colleagues at the KSTA, Dr. A.M. Ramesh, CEO, Dr. Anand, Senior Scientific Officer, Mr. Umesh, Senior Scientific Officer, and Mr. Srinivasu, Scientific Officer, and then several colleagues and friends who have joined online now and also on the YouTube, as I mentioned. Not going into details, with a very brief introduction, as we all know Dr. Aatre Sahab. He has been the Principal Scientific Officer, Director of the Naval Physical and Oceanographic Laboratory, DRDO in Cochin. He has been the Chief Controller of DRDO, and as I said, the Director General of DRDO and Scientific Advisor to the Defense Minister. In the recent past, he is actively involved in the design and development of micro and nano devices and systems. A fellow of several academies and associations, IEEE, IETE, INAE, IEE, Indian Academy of Sciences, the Aeronautical Society, Acoustic Society, Ultrasonic Society, and then, as I said, being the Lifetime Achievement Awardee of the KSTA, he is also the Honorary Fellow of the Karnataka Science and Technology Academy. Several national and international awards, including the Distinguished Alumni IISc, Naidama Award, D.S. Kotari Gold Medal, Indian Engineering Congress Gold Medal, Institution of Engineers Gold Medal, the Lifetime Achievement Award from the System Society of India and KSTA, honorary doctorates from University of Hyderabad and VTU, and both the important highest civilian awards of the country, Padma Bhushana and Padma Vibhushana. Also, the Lifetime Achievement Award of the Indian National Academy of Engineering and the DRDO, as also the Vignatam Award from Adi Chinchanagiri Mutt. And as I said, he is presently the chair of the Board of Governors of NIT of Goa, he was, and presently IIEST West Bengal. With these honors and with these accomplishments of lifetime, we have Dr. V.K. Aatre coming to the academy and virtually online. And great pleasure, sir, on behalf of all of us, thanking you and welcoming you to this special lecture series award. And the title of the talk today by Dr. Aatre is Science and Technology and its Institutional, Philosophic, and a Historic uh, Philosophic and Societal Perspective, all the dimensions of science and technology. With these, I once again thank you and welcome you to this talk, sir. Thank you very much.
Thank you. Good morning to you all. I'm glad to be a part of the Karnataka Science and Technology Academy lecture series on the 75th Swatantra Amruta Mahotsava of India. I must especially thank Mr. Ayappan for inviting me for this lecture series. Originally, he had asked whether I could talk something about the happenings of science and technology in India, and I thought everybody would talk about that. And I thought I would give a much broader perception of science and technology. I am sure you are all well aware what we have done in science and technology and what we are doing. So I thought I would give you a much more general talk. I beg your pardon for rather an onerous title, but I want to talk about something about history and what it has done to the society and what are some of the philosophical aspects of science and technology. We live in times when science and technology has become the greatest enterprise of mankind. Science and technology seem to control and modulate everything we do. The way we collect information and educate ourselves, the way we exchange information and communicate between us, the way we do financial transaction and business processes, our transport, our health and Medicare, and even the time we spend our leisurely time, all depends on the gadgets and systems that have come out of this enterprise. Science and technology are the engines which drive the progress and prosperity of a country. Technology, especially science-driven technology, is the one which produces wealth for the country. Science is the culture of a society. It is esoteric and often by accidental. But science changes our perception of the universe. Remember, the Pythagorean concept of the Earth-centric universe was shattered by Copernican revolution of sun-centric universe. Science also changes our perception of our role in the universe. Remember, Darwin's theory of evolution showed that the Earth was not created for Homo sapiens only. Homo sapiens were a small twig created in the last blink of a geological time in the phylogenetic tree of evolution. Technology is much more mundane. It is application oriented. It started from an artisan's work. The classical and philosophical role of science is to understand the patterns, regularities, and rhythms of nature and formulate equations that govern these in the elegant mathematical terms and numbers. But the other role of science is what we are interested in. Science begets technology. Science uses technology to produce more science. More science begets more technology. However, if you trace the history of science and technology, you will notice that science and technology grew independently for a long time. They were not interlinked at all. The interlinking of science and technology is a much more recent phenomenon. If you look at Mesopotamian civilization, Indus Valley civilization, we had some culture of science. But the modern science, to a large extent, depends on what Greece did. It was the Greece who made the science a secular activity that it is today. We hear of greats like Pythagoras, Aristotle, Democritus, Galen, Archimedes, Euclides, and a number of people. At that stage, science used to be called as a natural philosophy because it was looking at the problems of nature. Not everything the Greece did was right. In fact, Aristotle's equations of motions were all wrong and required a Newton to correct them. Galen, though, talked about anatomy and dissection. Many of the things which Galen did was wrong, and nearly 1,000 years later, Andrew Vesalius had to correct them. But Greece made it intellectually exercise. They did not expect science to be useful to humanity. In fact, there is almost a rumor that they abhorred application-oriented science. But the dominance of Greece was so great, nobody challenged them for nearly 2,000 years. That science was useful to humanity is a concept which was originated in the 17th century by Francis Bacon. Francis Bacon wrote a book called Novum Organum, New Organization, where he delineated what science could do. He also wrote a book called New Atlantis, named after a mythical island which is supposed to have submerged in Atlantic or Pacific. This particular island is somewhere in Mediterranean Ocean. On that island, he creates a house called Solomon's house. And he connects a group of people who will specifically work on the application of science to humanity. This clearly was the precursor to the modern research and research universities which are spread all over the world. This also triggered the formation of Royal Society, whose fellowship is the most coveted honor for a scientist. Incidentally, the motto of Royal Society is Nullis in Verba, take nobody's word, clearly indicating the independent verifiability of the science. But Royal Society did not talk of technology. Even other societies which were formed, for example, a society called Lunar Society, which was formed in Manchester, started by Erasmus Darwin, the grandfather of Charles Darwin, with a membership like Francis Bolton, Josiah Wedgwood, James Stevenson, and though they brought scientists and engineers together, they didn't talk about science and technology mingling. Even during the Industrial Revolution, technology came first, the equipments came first, and then one sat back and looked at whether we can explain it scientifically. However, during the 17th, 18th, and 19th century, a lot was achieved in science. In chemistry, we had Lavoisier, Priestley, Charles, Boyle talking about gas and gas laws. We had Mendeleev bringing out his beautiful table, periodic table. And then there was Dalton who promulgated the atomic theory the first. In medical profession, Harvey talked about the blood circulation. Jenner, Pasteur, Lister talked about various health-related issues. In biology, Mendel looked at the hereditary factors. And of course, Charles Darwin wrote probably the most famous book in science, The Origin of Revolution. And Professor Galton talked about eugenics and started the debate, or nature or nurture. In mathematics, we had greats like Euler, Leibniz, Laplace, Gauss, Riemannian, looking at the beauty of mathematics. Incidentally, there is a very interesting story attributed to Euler. Euler comes from a small state, a city called Königsberg in Prussia. Königsberg had a river, they had 4 land masses connected by a river called Pregel. And all these land masses were connected by 7 bridges. A problem that was proposed to Euler was Can somebody start from one landmass, cross all the 7 bridges only once, and come back to the original starting point? Euler analyzed this and said it's impossible. And then thus laid the foundation stone for a very important part of mathematics called graph theory, which finds very wide application, including computer science. In physics, Volta, Ampere, Faraday did a lot of things to bring electricity and magnetism together. And finally, the Scottish physicist James Clerk Maxwell put them all together in his famous Maxwell's equations. So much had been achieved in the 17th, 18th, and 19th century that Lord Kelvin was very famous for Kelvin's temperature degree. William Thomson is supposed to have said, everything that has to be done in this science has been done. There is nothing else to do, except perhaps refine the experiments and perhaps add decimal places to the constants of nature. Little did he anticipate that two of the most beautiful theories were just lurking down the corner. In 1900, while doing experiments on a black body radiation, Max Planck found that he could not reconcile the experimental results or the theoretical results unless he assumed that the energy came in packets, which at a later stage was called quanta. Einstein proved the same thing when he did the photoelectric effect and won the Nobel Prize on that. The next 30 years shook physics. We had Erwin Schrödinger, Werner Heisenberg, Louis de Broglie, Pauli, Dirac, all of them put together developed the most complete, fascinating, weird theory called quantum mechanics. Quantum mechanics finally led to the invention of transistor in 1945. Rest was history of electronics, perhaps the history of technology itself. Between 1905 and 1915, Einstein really did a revolutionary showing that Newton's concept of absolute space, time, and motion were all incorrect. He formulated a set of new equations which connected the curvature of space to the energy and mass in the universe. The energy and mass itself dictating the curvature, and the curvature dictating the planets move in a particular direction. In fact, the result of Einstein's theory was something weird, that time and space were created simultaneously by an event which later on was called Big Bang. And Einstein's theory also introduced all kinds of weird objects: supernova, black holes, gravitational lens, gravity waves, time dilation, etc., etc. If you don't account for the time dilation of 48 microseconds, which happens between the satellite-based clock and a ground-based clock, the 24 constellation of satellites won't have resulted in the most important gadget we use, the GPS system, global positioning system. So here you see science and technology was getting together. Science and technology were being coupled in the early part of the 20th century and became inseparable twins and created marvels of technology. Before I talk to you about marvels of technology, I want to point out to you one other aspect, a very important aspect of science and technology. Today's mankind faces many predicaments. Some of those predicaments are due to the fact that we are overusing and unwisely using in an unsustainable way all the resources of the earth. I can talk about difficulty in providing potable water, huge amount of nitrogen content in the atmosphere, cyber security problems, and so on. Several of those problems are all predicaments which we are facing. But I want to spend a couple of minutes on only one issue: energy. World produces 600 exajoules of energy per year. Exa is 10 to the power of 18. 85% of this energy is generated by fossil fuels, coal, petroleum, or natural gas. World produces 20 petawatt hours of energy per year. Peta is 10 to the power of 15. Again, 60% of them is generated by fossil fuels. In generating this energy, we have created a real problem for humanity, which we all know, the global warming. So much has been written and talked about and said about this. I don't want to spend any time on global warming, except to point out some of its effects. Sea surface temperature rise, and hence its effect on the marine organisms, melting of glaciers and sea level changes and flooding of the coastal regions, changes in the seasonal pattern, and extreme weather conditions like no rain or heavy rain, floods, and so on. All these are due to the weather patterns we have created because of our overuse of fossil fuels and things like that. Most of you may recall in the recent past in Paris, we had a convention, and all the nations agreed that we are trying to limit the temperature to 2 degrees centigrade increase, if not 1.5 degrees. Because if the temperature rises to 3 degrees, we may have a non-reversible cataclysm on the earth. What are the things we have to do? Obviously, we have to reduce the amount of greenhouse gases we divulge into the atmosphere, like carbon dioxide, methane, water vapor, and so on. At the same time, we have to extract the carbon dioxide from the atmosphere and bury it deep down the earth, what is called carbon sequestration. Switzerland already has built a plant like this. But many scientists and politicians believe that we will not be able to achieve this before 2050 because of political reasons, because of economic reasons, because of technological reasons. So science and technology again has created a very interesting field called geoengineering, which wants to build a huge umbrella to protect the earth from sun by spraying certain sulfur aerosols in the stratospheric clouds, or even building huge space mirrors which reflect the temperature away from this. Even in energy, we all know sustainability of energy has become very important, and your solar energy becomes one of the most important issues. Solar energy produces about 300 watts at the surface of the earth. And at the upper reaches of the atmosphere, it produces 1,400 watts per square meter. So US and Japan have a program to build huge solar collectors in the upper atmosphere, convert the energy collected to the microwave energy, beam it to the earth, and reconvert it back to electrical energy. Japanese are, I gather, intended to build an offshore island to do this. So you see, science and technology producing marvels at the same time has to solve the predicaments that humanity faces. Let me talk about a few of the science and technology marvels. In communication, we started from Marconi's wireless, then created Bell's line communication standard telephony, and we are back to again wireless and created the ubiquitous cell phone, which provides us unimaginable connectivity. We all know that cell phones are not mere just phones. We have created computers of all kinds and interconnected them from terminals called LANs, WANs, local area networks, wide area networks, and so on, and finally create the World Wide Web, which puts all the information literally at our fingertips. We talk of cloud computing, we talk of edge computing, fog computing, and so on. Now we are trying to mix the two, the communication of cell phones and the computers, the networks, and create new fields, cyber physical systems, Internet of Things, which is going to change the day-to-day living in the near future. We have created an army of robots. Robots for industrial application, robots to work in dangerous atmosphere, and robots for household application. I have a feeling in the next few decades, household robots would become as common as household appliances of today. We talk about intelligence robots. Robots which can observe, interact, and communicate with the nature and learn like a child does. We talk of biorobotics. We also create artificial intelligence. Somewhere in the 50s, Marvin Minsky and Herbert Simon introduced a new field, and for suddenly we had what are called expert systems going on. But AI did not really meet the kind of goal it has set. But now it appears in different avatars. We talk of machine learning, deep learning, and AI has found now percolated into all fields of human endeavor, including agriculture. AI, along with robotics, is threatening to create a machine which, down the road, we may not be able to distinguish between the creator and the created. Starting from a concept called population inversion, we created lasers. Lasers can be used in industrial application. Lasers can be used in communication. At the same time, lasers can also be used to find a very delicate ophthalmic surgery called LASIK surgery. Today we talk lasers on chips. We have created a new field called photonics. We have created amazing imaging systems. We can image the tiniest, the very atoms. At the same time, bring back unimaginable images, mega galaxies, billions of kilometers away from the Earth. See what science and technology has done for our favorite toy, automobile. Today's automobile is becoming more and more sophisticated with dozens of sensors, dozens of microcontrollers. And today we talk about autonomous vehicles, driverless vehicles, and several countries have, a few countries have already started introducing them. We have come a long way from Kitty Hawk of Wright brothers. And we have huge aircrafts which can carry hundreds of passengers if necessary at a supersonic speed. We have created space launchers which can propel satellites to the outer reaches of the solar system and indeed even into the interstellar space. It's possible before the middle of this century, we might have built human colonies on the moon. And perhaps by the end of the century, human colonies on Mars. We are talking of propulsion other than chemical propulsion, photonic propulsion by light, which can propel objects to 10% of the velocity of light, which will reduce the travel to Mars to 3 hours instead of 3 years. The US has already a program to send probes through photonic propulsion to our nearest celestial neighbor called Alpha Centauri, which is 4.5 light years away. But the most important invention which has propelled everything else is microelectronics. Starting from a speech which Richard Feynman, Nobel Prize winning physicist from Caltech, talked about, that there is sufficient room at the bottom, microminiaturization keep on extending. Initially, it started from 6 transistors on a chip. Today, you have millions of transistors on a chip, which is 1 centimeter by 1 centimeter. We talk about 7 nanometer line widths. In fact, in the laboratory, there are 2 nanometer line widths. One step away from the micro is the nano. Nanotechnology is there today. I agree. Nanotechnology has not produced the molecular assemblers, self-replicating robots, which Eric Drexler talked in his famous book, Engines of Creation. But today, micro nanotechnology has given us power to build systems which are as sensitive, as optimal as what nature has created of millions of years of evolution. The micro and nanotechnology has percolated beyond electronics. It has been extended to mechanical systems. You can build beams, you can become cantilevers, you can become levers, you can become ratchets, you can build motors, pumps, micro needles, micro tweezers, nano tweezers, and so on. I have been working in this field for the last 10 years. It's a very fascinating field. It has a major application in health and medical sciences. We have what is called point of care test kits, POCTs, which is a small chip. And if you put a drop of any biofluid, it can detect the body fluids, it can detect biomarkers. Already chips to detect hepatitis, dengue, TB are in the market. They can be used in remote sensing places. We can build drug delivery systems. We have wearable systems for health monitoring. You already know that this kind of a wristwatch or arm band which the athletes use or even a con man use to continuously do health monitoring these systems. So we have different kinds of wearable systems. We have swallowable systems. For example, endoscopic pill, which contains a CCD camera, a signal processing chip, a Bluetooth chip, and a micro battery, all packaged in a transparent biocompatible polymer. If you swallow the pill, it goes through the GI tract and produces images which can be transmitted to the external monitor. Koreans are even trying to build locomotion so they can revisit the place. We have what are called smart pills. If you swallow the pill, they go and stick to the stomach and release medicine at a particular space. Even origami, a Japanese origami is entered into the smart pill area. Wearable systems, swallowable systems. Now we have injectable systems. The work going in Harvard University on what is called a conducting polymer has a conducting polymer mat with nano electronics embedded at the various junction grid points. And you can melt them in a liquid and inject them into the brain. They open out like a mat and cover a huge area of many neurons. And perhaps it will be used to trigger a neurotransmitter called dopamine, which is probably going to reduce the Parkinson's disease symptoms. So there is no end. Science and technology has had profound effect even on health sciences. Starting from an accidental discovery of Rontgen on X-rays. Today, we have all kinds of diagnostic systems. Ultrasounds, CATs, spiral CTs, MRIs, functional magnetic resonance images, and so on, without which today's physician will not be able to do prognosis that clearly. Our cloning activity has gone much beyond Dolly the sheep. We have cloned monkeys and other animals. The only reason that we might not have cloned human beings is because the ethical question it raises. Recently, we have a gene editing system called CRISPR-Cas9. The creators of that won the Nobel Prize last year in chemistry. It's a system which can insert, delete, or add codons into the system. In fact, Chinese wanted to create CRISPR babies. And there was a huge hue and cry on the, again, ethical questions that it raises, so that I abandoned the project. In fact, we have finally started understanding the most complex organ created by millions of years of evolution, the human brain. Few years back, we didn't even understand what we considered a simple phenomenon called sleep. Today we understand a lot of things about sleep. And we have coupled sleep deprivation to kind of dementia. We also know how neural systems build plasticity. The plasticity continues even at 60, 70 years age, your neuron connections change. We are wondering whether we can build such kinds of plasticity to our computer networks. We clearly know now, or at least very clear, how the long-term memories get stored and how the organs like amygdala, hippocampus, or cerebral cortex works. Maybe in few years, we will also know what is it meant to be conscious and where is it residing. So you see, look at the kind of marvels that science and technology have created. We have many other fields. I can go on and on for next few hours indicating what are the marvels of science and technology. For example, we talk of 3D printing. You can print a building. I have seen a printed car. Recently, a steel bridge, printed steel bridge, 3D printed steel bridge, was installed in Amsterdam in Netherlands. We have materials called MOFs, metal organic frameworks, which could extract moisture from really an arid atmosphere of 20% of less moisture, and look at what it could do to desert climate to extract water when you're running short of water. We have intelligent bionics, intelligent hands, intelligent foot, not only contented bioelectricity, by many other kinds of things. We talk of printed organs, 3D printed organs. And there is a new area called transhumanism, which is an area where the human attributes can be improved by embedding electronics, cyborg kind of systems. You can put systems in a chip to improve your memory. So you look at the way science and technology is growing. These all look like science fiction. But today's science fiction becomes tomorrow's technology. So that is the beauty of science. For example, in 1964, there was a movie called Fantastic Voyage. The movie is built around US capturing a Russian general and want to extract intelligence from the Russian general. But he has suffering from cerebral thrombosis. There is a blood clot at an area which cannot be easily reached from outside. Mad scientists strike. They build a submarine. They put 4 people, the doctors and the paramedical people, laser technologists into that submarine. By irradiation, they shrink the size of the submarine to a nano size. And that submarine is injected intravenously into the general. The submarine navigates itself through arteries and veins, finally reaches the brain, and a laser scientist dissolves the clot. But by this time, the body's defense mechanism has woken up and attacks the submarine and destroys the submarine. But the 4 people are removed out of a teardrop before they gain the original size. Pure science fiction, is it? Many of the technologies which we talk about are available today. But should we use those technologies? Should we use such technology to enhance the human thing? One thing is increase. We want to look at longevity. We want to improve our memory. We want to improve our career. Look at the Olympics. Every year, every time Olympic comes, there is more and more records being broken. Can we enhance the performance of human using big technology? Is it ethical to do it? So science and technology is a dual-edged sword. It can help us, it can be used, it can also be abused. Abused by intent or otherwise. Look at what happened when we did nuclear fission. We created a huge amount of atomic energy. The same fission can also create weapons of mass destruction. We talk about nanoscience. Nanoscience can do many things, but do we really know the ultimate toxicity effects of nanoparticles? So science, you see, nothing comes without a danger. So what we have to do is think about how to use science as Bacon thought in 17th century. Today there is a new definition of a geological epoch called Anthropocene. Instead of Holocene epoch, we call it Anthropocene epoch. The epoch during which anthropogenic activities, human activities, has created a large impact on the geology of the earth and the environment of the earth. Of course, we already know the effect of what happened in the ozone holes. We know what's happening to the global warming. Biodiversity is decreasing and the extinction of many species. We have encroached most of the areas and reduced the area available for the other animals. Maybe this is the reason why pandemics spread. We have reduced the biomass of the earth. We started using plastics and created the microplastics. And we have got millions of microplastic in the sea water. So you see, science and technology comes with a rider. Science and technology is not going to be all hunky-dory and only useful. You have to use that with a modicum of wisdom. And also, in the coming years, science and technology is too important to be left to only science and technologists. Lawyers, psychologists, philosophers, administrators, general society must decide what is the amount of science and technology do we need. What is fit for human intervention? What is not fit for human intervention? Science and technology is a steamroller. You can't wish it away. It's going to come whether you like it or not. If 30 years back when I was in the DRDO traveling all over India, if somebody had said cell phone technology will grow in India, I would have doubted. But look at how cell phone technology is spreading in India. So science and technology cannot be prevented. We have to decide what is the kind of role we play in science and technology. What is the amount of science and technology we will accept? So I keep telling many of the scientists whom we meet whenever they conduct an international seminar, please arrange a session where it talks about the impact on the society. The impact of science and technology is too huge. In fact, if you get up in the morning, if you want to start listing the gadgets you use, the things you perform, how would you have done it without technology? So science and technology is too powerful. We can't, as I said, we can't wish it away. But is science and technology ever going to end? Is there a point when we say, that's it, there's nothing to be done in science and technology? As Lord Kelvin said in 1899, that nothing, everything has been done in science, nothing more to be done. Are we going to reach a time when you turn back and say science and technology over the last 4 or 5 million have reached a stage when there is no further development? We thought there was no further development few years back. Now we have drones. We have drones for all kinds of applications. We have drones for all kinds of sciences. It can drop a bomb. It can do the surveillance. It can deliver organs. It can deliver like Amazon want to do material. What next? We have pumped up UAVs, which contain all kinds of sensors if you want. Temperature sensor, magnetic sensor, chemical sensor, visual sensors. can be used for crowd control, it can be used for aerial photography, it can be used for monitoring or surveillance. So you see, technology is everything producing newer things. And in the space of introducing the new technology is increasing. The so-called mind to market now is very short. Even in India, though we are not really a powerhouse in science and technology, we are catching up with science and technology very fast. When transistors were introduced, we took about 2 to 3 decades. When computers were introduced, we took 2 to 3 decades. When laptops were introduced, we took only about 10 to 15 years. When cell phones were introduced, we took only 5 years. And today, 3D printing, you go to any university, there is a 3D printing machine. So the technology gap of introduction in India is becoming less and less. We have started becoming slowly major players in science and technology. Indians are very good. They are at the hub of many of the technological development. So as we celebrate our 75th Independence Day, we should also define our role of what we want to do in science and technology. Sometimes we should sit back, think about, as I said, how much of technology we need. But I am sure we are never going to reach a stage when we said everything in science has been done. I want to leave you with a beautiful quotation from a Nobel Prize winning physicist John Wheeler, who was then in Princeton University, who happens to be the mentor and guide for Richard Feynman, another extraordinary Nobel Prize winning physicist. John Wheeler says, I quote, knowledge is like an island which shores for its ignorance. As the knowledge grows, so does the shores. Let me repeat again. Knowledge is like an island which shores for its ignorance. As the knowledge grows, so does the shores. Unquote. Thank you very much.
Thank you very much, sir. It was such a scintillating talk. So many thoughts and ideas that you brought to fore, and quotations. The last quote was also so very interesting. Thank you so much for this talk. Amazing. You touched all dimensions of science and technology and applications. Grateful to you. We also been joined by the Lifetime Achievement Awardees, Dr. V. Prakash, Dr. H.R. Krishnamurthy, with us who are here now, Dr. R.S. Deshpande, Dr. Srikanti Swami, seven others who are joined in just when we are starting. I introduced the others. So great welcome to all the colleagues who have joined. Sir, once again, grateful to you. What a talk it was, and we are just in the process of assimilating those, and the talk already came to an end. It was such a brilliant talk. Thank you very much. At this time, our esteemed colleagues, invitees, audience, if you have comments and any suggestions, any questions to Dr. Aatre Sahab, you are welcome. Any comments, Dr. Prakash?
Dr. Aatre, brilliant talk, and we almost recollected our earlier days of talking to you, either in the airport or anywhere. I have a very important question. The role of human imagination to cross innovation and move into an area of mind travel is not too far off. And it's going to be the future if we have to achieve many things. Are we close to this, or when we are far off from this, with the challenges of interdisciplinary interaction becoming less and less every day on one side? But in certain areas, it is increasing. So mind travel, is it going to be a mind-boggling problem forever, or are we going to somewhere address it? Thank you, Dr. Aatre.
Yeah. Thank you, Prakash. I'm glad to see you after a long time. We haven't met either for obvious reasons. We are not able to meet. Otherwise, as you said, you used to meet quite often, at least in the airports or other places. I am not sure I have an answer, but I want to point out one thing. In somewhere in 60s or 70s, IEEE transaction produced a series of articles on communication channel produced by brain to brain. The way they did it was somebody was watching some scene in California and somebody was painting that scene in New York. So whether this ESP kind of a thing is possible, I am not sure. And I have a feeling today in science, you cannot say anything is impossible. Science has made impossible possible and unachievable achievable. Recently, I had watched this PhD thesis in Indian Institute of Science, where a small car, which the toy car, was being controlled remotely by concentrating on a mind by a student. This was done by students of one professor, Anant Suresh, in mechanical engineering department. So today, if you are going to ask any scientist, I am sure they will say, is mind travel possible? The answer is yes. When? We don't know. You see, I said, I want to digress a little bit here. You know, when we all started watching when we in 60s, the show called, I forget the name of the show. Anyway, when US Enterprise and Captain Kirk were all being told, they said warp speed, speed of light. Today we have photonic propulsion in the laboratories. And when you reach the speed of light, you know you don't age. The time dilation is complete. So is it possible we are going to, during the Amruta festival, maybe we are going to have a Amruta as the eternal spirit? Possible. I am sure you and I won't see it, Prakash, but our great-grandchildren may perhaps see what is meant by mind travel. Is it possible to communicate? Then we are looking at a different dimension altogether. So what are the end of the science dimension? I don't know. But today, no scientist will absolutely say no to your question. All of them would say, perhaps. When there we have to throw our hands up and say, only God only knows. Thank you.
Thank you, sir.
Thank you, sir. Thank you very much. Dr. Kushal Das has a question. Dr. Kushal Das, unmute, please.
Yes, sir. So thank you very much for giving an opportunity to interact with legendary Professor Dr. V.K. Aatre, sir. Sir, it was an amazing talk. First, I'd like to tell that you are a role model for all of us, and definitely your talk inspires the generations together in every steps. So this is the very interesting talk you have given, a history or recollection of the history and reminding us and refreshing us about the scientific background of the world and now currently what is going on. And also Dr. V. Prakash sir has made the future aspects also. It's really travel. I feel we travel to the journey from the past to present to future. It's a really wonderful to completion by Dr. V. Prakash sir. Sir, my question is very simple. My question is, do you think or believe that too much thrust on patenting on science, specifically in India, is it actually inhibiting and blocking the prosperity of mankind based on science and technology? Sir.
I don't know. You asked a very philosophical question, which we can debate for hours together. I'll tell you, I have read several books and articles. Is science the salvation? Can science answer all questions? In one of the thing, like there's a book, the Mind of God. You know, is the book when you see what it is when the book was written and read about that, and looked like that. So the question is, if you sit back and be honest, and if you look at science on one side and religion on the other side, both of them try to answer the same question. How did it all begin? Where do we come from? How is it all going to end? If you know the answers for these things, we have solved the conundrum of the universe. I have a feeling we will never answer this question, because the universe is going to keep not only expanding, our knowledge is expanding and so on. So one cannot say science will answer all questions, or science is the end of everything. But the point about technology is something different. Technology doesn't answer any questions. It provides you gadgets. How are you going to use? For example, we are now talking of virtual reality. You look at what is that it could create. You know, you can go inside and travel inside human being, travel inside something else. So the imagination of science is something everybody. J.B.S. Haldane once, I suddenly remembered a quotation. J.B.S. Haldane once said, "The world is not only weird than you think, it's weirder than you can ever think." So that is the dimension of science. None of us know what is the dimension of science. If you sit back and look at Einstein's relativity before you put it up, you look at how is it possible? How can science be created? Science and time getting science time, the fabric of space is science and time, the space and time. Would you have believed it? No. So the science throws up matters, but it is the technology which makes it applicable to your ordinary human being. Talking about science to an ordinary human being is meaningless. On the other hand, talking about science, technology, and engineering has some meaning for you and I and other citizens. So science should be looked at as it's a culture. It's a culture that we have developed, and it's not going to go away. Okay, in India we have not done that much, but we have had a culture of science for hundreds of years, thousands of years. But we have not achieved the kind of level we could because we did not develop technology. Science by itself, knowledge by itself, data by itself is meaningless unless you use them. So India did use the knowledge it had to produce technology, because the technology which society accepts. Science is okay, esoteric, some people can think and look and debate, but it's normal, mundane things has to be answered by technology. That is where India hasn't done it, and of late it's been doing it. You know, our talent is so huge.
Yes.
You go to a village, you can't say villagers are dull. There are as sharp villagers as there are in urban areas, if not sharper. I am involved in an organization called Agastya when we go to villages, and I see amazing amount of curiosity and motivation. So I am sure very soon India is going to become, it cannot be prevented to become a supermind. Question is whether we will see it in next 10 years, 2 decades, or 3 decades. Maybe in the 75th anniversary, we should decide in next 20 years, we are going to become a dominant science and technology organization in the world. Thank you.
Sir, just thank you. Sir,
Thank you, sir. Dr.
Sir, last one thing that, sir, do you feel that medical sciences research is far behind as compared to the other technological branches of research in India?
In India, yes, absolutely. We virtually do nothing in bioelectronics. Everything is imported. You see, we are excellent technology absorbers, but we are not creators of technology. We quickly absorb technology and use it, but we must become creators of technology. And human being is such a classical, as I said, if you look at the brain research going on, only now we understand. We know deprivation of sleep produces dementia. Deprivation of sleep does not allow enough toxic chemicals to be removed from the brain, and it gives dementia. So we are learning newer and newer things. Medical is not an exact science. There are too many variables in human body to say it's a precise science. The more you add, more you think. But on the other hand, as I said the last quotation, the more you know, the more you seem to not know.
Thank you, sir.
Thank you.
Thank you, sir. Dr. R.S. Deshpande has a question. Dr. Deshpande ji.
Sir, good afternoon. It
Welcome.
was
Go ahead.
like the human brain does not have any limit. Your lecture also was such that it was almost limitless. It's wonderful. In fact, I failed in my speed to take the notes. That apart, sir, you are really a Bhushana. That apart, I have a simple thing. Science for society. Professor knows that I'm writing one thing on that. Science for society or society for science. This is a question. That the demand-driven science and the supply-forced science. Certain sciences are supply-forced without knowing the externalities. You have said about the plastic and microplastic. Without knowing the externalities, science is forced upon the society, whether it is demanded or not. Now, scientists rarely seek the demand and derive, like vaccines. The demand was generated and the vaccines were derived.
Did you complete your question?
There seems
Thank
to
you,
be
sir.
some problem.
Yeah, you see,
that-
let me make a general comment. Science for society or society for science is not a point we should debate. Without society, there is no science. And today, science has become so dominant that science is a part of the society. That's why I said society is very important. If society doesn't need it, why do we need science? We can go back to the Stone Age period. We can't. Can we go back and say when we didn't have a cell phone, we were really reasonably happy to be lived a normal life. Today, if you withdraw the cell phone, I have a feeling we will not be able to live that life. In fact, if you go out without a cell phone, you keep telling, what did I say? You're not a cell phone, I couldn't contact you. All that you took was 2 minutes extra. You cannot differentiate science and technology. Science and technology have become now inseparable twins, and it has become a part of the society. All I am saying is you must decide what is to be used. Where will you intervene? For example, if we are going to do longevity experiments, if we can enhance the age, do we make everybody immortal? Even if you can, do you want to do it? If we can do genetic engineering and see that nobody gets a disease, do you want to do it? There are ethical questions. The ethical questions have to be answered by the society, not science. So society and science, I have a feeling you cannot distinguish. They intermingled, intertwined. Okay?
Thank you, sir.
Scientists
Thank you very much.
can think
Thank
further.
Yeah, thank you very much. Grateful to you, sir, for this elegant talk. And Academy is proud that we are able to have you on this platform. And as was seen, it was such an intellectual discourse that was going on. We wish we had more time. And then I'm sure our colleagues, audience would be in touch with the Academy as we go along. At this time, profusely thanking you for being with us on this occasion. We would also like to mention next week, same time, that is the 11th of August, Wednesday, 11 o'clock, we have Dr. H.R. Krishnamurthy, former Additional Director General, Doordarshan, Government of India, coming on with on science communication. It's another thing that you were mentioning on with regard to science and society. So he would be touching upon some of these, science for society. That dimension will come up. And then in your elegant lecture today, you brought out, this point will remain with us. There can be no science without society. I mean, you brought out that importance of society, the context for science. Thank you very much, sir. Grateful to you from all of us.
My
And
pleasure.
now I would request Dr. A.M. Ramesh, the CEO of the KSTA, for his words. Dr. Ramesh, please.
Namaskara. Good afternoon, sir. We have listened to a very scholarly and enlightening talk on science and technology, historical, philosophical, and societal perspective by distinguished scientist Padma Vibhushan, Dr. V.K. Aatre, sir, former Director General of DRDO and scientific advisor to the Raksha Mantri. On behalf of KSTA and all the participants who have joined on Cisco WebEx and YouTube platform, I thank Dr. V.K. Aatre, sir, immensely for this illuminating talk. Thank you very much, sir. I thank profusely our Honorable Chairman, Professor S. Ayyappan, for initiating this very popular Bharat Swatantra Mahotsava series of talks. Thank you, sir. I am grateful to our esteemed members of KSTA, Professor P.G. Mulimani and Dr. A.E. Eknath for joining this webinar and encouraging us. Thank you very much, sir. I am thankful to KSTA Lifetime Achievement Awardees, Padma Shri Dr. V. Prakash and Dr. H.R. Krishnamurthy, and distinguished scientists Dr. Ramakrishna, Dr. R.S. Deshpande, and Dr. Girija Shivkumar for joining this webinar. I also acknowledge the presence and thank senior academicians and scientists who have joined this webinar. Professor Kushal Das, thank you very much, sir. Professor P.M. Patil, Dr. Muli Mani, Dr. Shrikant Swami, Dr. Shanai, Dr. C.D. Patil, Gayatri Sudhir, Preeti Rajesh, Dr. Vanita Krishna, Dr. Suresh, Dr. Arundhati, Dr. Shubha, Dr. Tabassam, and Dr. Satyantan for joining us on this occasion. I also thank all the participants who have joined this webinar on Cisco WebEx and YouTube platforms. Thank you very much. As our Honorable Chairman has told, next week on 11th August, we'll be having one more distinguished talk by Dr. H.R. Krishnamurthy, former Director General, Prasad Bharti. I request all of you to kindly join and encourage us. Till then, thank you very much. Be safe. Thank you, sir.
Thank you, sir. Thank you very much. Grateful to you. Thanks to everybody.
Thank you.
Thank you very much. Thank you.